Welcome back to Math with Miss Reimer. Today we are looking at Section 6A, Product Rules of Exponents. Couple things just to review. Your base is the large number and your exponent is the little number, and they tell you about repeated multiplication. So the exponent tells you how many times to multiply the base by itself. This entire thing is called a power, and we'll be using that vocabulary a lot as we continue. Also, Sally says hi. Three properties we're looking at today, the first of which is product of powers property. That comes when you have b to the m times b to the n equals b to the m plus n. So what that means is that you are allowed to add the exponents of any two powers that have the same base. So, for instance, in 3 to the 6th and 3 to the 4th, because both of them have the same base, I can add the exponents together to give me an answer of 3 to the 10th. When we do some example problems, 2 to the 6th times 2 to the 8th will equal 2 to the 6th plus 8, or 2 to the 14th. As you get more familiar with these, you will probably start to skip this middle step, which is fine. Over here in my m's, this first variable, since it doesn't have a given exponent, we assume that it has an exponent of 1. Think similar to how there's always a coefficient of 1 on a variable that doesn't have a given coefficient. So in this case, we have 1 plus 5 plus 6 to give us m to the 12th. In number 3, we again have a negative 3 to the 7th and negative 3 to the 1st because there is not a specific exponent that is given. So we add the 7 and the 1, and then we will get negative 3 to the 8th. It's important that that negative 3 stays in parentheses. When a base is negative, you always have to keep that base in parentheses. Otherwise, your answers will not come out correctly. In number 4, we have 7 to the 3rd, negative 7 to the 3rd, negative 7 to the 1st, negative 7 to the 4th, to give you negative 7 to the 8th. Keep in mind that you have to keep bases negative because, for instance, if we had negative 2 to the 4th and negative 2 to the 4th, if you were to put both of these in your calculator, you would find that this one comes out to be positive 16, whereas this one comes out to be negative 16. The reason for that is this problem means negative 2 times negative 2 times negative 2 times negative 2. 4 negative 2's. When I go to multiply these together, they'll cancel to be positive 16. This problem, on the other hand, means negative 1 times 2 times 2 times 2. So the base here is 2. The negative is hanging out front like a negative 1. Multiply all these together, you get 16 times a negative 1 is negative 16. So the key here is when you mean your base to be negative, it has to be in parentheses. Anytime that it is not in parentheses, it's assumed it's a negative 1 hanging out front and is not a part of your base. The next set of properties we are looking at is power of a power property. These come when you have a to the m to the n, that is, you take a power to another power. And these come because you can multiply the powers together. So m times n, and then still keep your base of a. This is because you are taking the power to its own power. So for instance, if I take 2 to the 3rd to the 2nd, that means I need 2 of the 2 to the 3rds. So it's actually like 2 to the 3rd times 2 to the 3rd. Well, using our product of powers property, we can add these exponents and we'll get 2 to the 6th. Notice then that's the same as if I just took my 2 times my 3 and got my 2 to the 6th. So that's why power of a power property works. In your examples here, we get 3 to the 3rd to the 6th, multiply those two together, and we get 3 to the 18th. In our actual examples, when we have a base of negative 12 to the 7th to the 6th, we can multiply the 7 and the 6 together, and we get negative 12 to the 42nd. That negative 12, again, has to stay in parentheses to note that my whole base is negative. In number 10, we can multiply the 2 and the 5. To give me d to the 10th. In number 7, we're still going to multiply the 4 and the 3 to get x minus 3 to the 12th, but then I'm done. I cannot go any farther. Because there is addition and subtraction inside these parentheses, that prevents me from taking that 12 any farther into the parentheses. Addition and subtraction are an exclusive club. They don't let anything into their parentheses, and so you're done from here. The reason that is because if I had x plus 3, and I tried to square it. What this actually means is x plus 3 times another x plus 3. When I multiply these out with a process called foiling that we'll learn eventually in the spring, I get x squared plus 6x plus 9 as my equation. Now, if you took the 2 in here, you would think it'd be x squared plus 9, but you miss that middle term. So, moral of the story, anytime there's an addition or subtraction inside your parentheses, that is stuck in your base. You cannot go any farther. Simplify what's outside, but then that should be stuck in your answer because you can't go any farther than that. In number 18, we get 13 to the 3rd to the 10th, so we multiply the 3 and the 10 to give me 13 to the 30th. In number 9, we get negative 8 to the 21st. And in number 10, this is again a scenario of the plus and the minus, so you keep the w plus 8 as your base, and you take that to the 18th power. You cannot go any farther than that because you cannot take 18 in. Our next property is power of a product property. And that means that when you have an exponent outside of a parentheses with more than one thing in the middle, you can take that inside. So that means this m can come to both a and b. In an example, for instance, this 3 can come into the m and the n, so we get m to the 3rd and n to the 3rd as well. At this point, we're going to start simplifying completely, that is, evaluating all of our powers. So far, we left things in exponential form because this would be a super large number, but in these ones, we're actually going to evaluate out all of our exponents. So in number 11, you take the 3 into both pieces. You get negative 5 to the 3rd and p to the 3rd. Negative 5 to the 3rd evaluates to negative 125, p to the 3rd. You no longer need this in parentheses because it's just a negative number without an exponent. You could put it in parentheses if you want, but you don't have to. In number 12, we take the 3 into both pieces. We get negative 3 to the 3rd and y to the 15th because I multiply those. Since this one didn't have an exponent already, think of it like it has its invisible exponent of 1. So 3 times 1 will just give you 3. Negative 3 to the 3rd is negative 27, and then y to the 15th. In our last examples, we are going to see some larger powers we're going to combine. The first thing we always want to do is get rid of parentheses. Think just like when we do equation solving. So you will take your exponents and multiply them inside to your parentheses sets. We will end up with 2 cubed, m to the 3rd, and m to the 20th from over here. All of these are still being multiplied together. When we go to combine like terms, 2 to the 3rd evaluates to 8. M to the 3rd times m to the 20th. We can add these exponents together, so we will end up with m to the 23rd. And 8m to the 23rd then is my final answer. I can't simplify any farther than that. In 14, we take our exponents outside of our parentheses and multiply them in first. So we get 3 squared, a to the 8th from multiplying, 2 squared, b to the 8th, a to the 16th. Multiply any existing exponents that are there. Now I'm going to simplify. I need to combine like terms and evaluate any exponents that I can. So I'll just go down the line. 3 squared is 9. My a's, I have another a to the 16th over here. These are being multiplied, so I can add their exponents together to get a to the 24th rather. 2 squared is 4, and then b to the 8th doesn't have anything to be combined with. Again, these are all still being multiplied together. So when I go to combine my 9 and my 4, I'm going to multiply them together to get 36, a to the 24th, and b to the 8th. Notice that convention is I write these in alphabetical order, so a comes before b, and then your number or your coefficient always goes in front. Something else to keep in mind is that if your base is negative and you have an even exponent, you will end up with a positive answer. For instance, if you take negative 3 and you square it, you will end up with positive 9, because this is negative 3 times negative 3. Whereas if you have an odd exponent, like negative 3 cubed, this will give you a negative 27, because this is actually negative 3 times another negative 3. 2 of these cancel together to give you positive 9, but you still have that one negative left, which is where that negative is coming out of. So when you have a negative base, if you have an even exponent, you should get a positive answer. An odd exponent will leave you with a negative answer. That's all for today from Miss Reimer and Sally. See you next time.